Because I think in math, and it has been a few decades for me, but they generally don't separate the DE and the DX, and you treat them like two different entities. They sort of are bound together in my recollection. But, I mean, they are two distinct things, just infinitesimally small. And you're just looking for the ratio of them. It's legitimate math, that's what I'm getting to. Even if the math people don't write it this way. The advantage of physics is that we have to pay attention to the math, but we don't have to be quite as formal in the mathematics for it. Okay. Any questions before I erase?
Nope.
I need that one still, so. Leave that for now. All right. All right, so the drawing I have over there of my electric field going this way and my magnetic field going out like that. So now what we're gonna do is we're gonna just sort of look at it from that point of view. My magnetic field's going up and my electric field is going away from us. So now, as I'm looking at or in English, as I look at my magnetic field, I'm basically going to be drawing a box like that. I have some magnetic field here, and get at least some contrast here. And then over here is B plus dB. And my electric field is going away from this now because it's rotated like that. My electric field going in. My distance here is some infinitesimally small distance, and my height, again, h, some arbitrary letter, just that we'll get rid of later. We'll employ the right-hand rule again in order to get the direction that we're going to go here. The fact that my electric field is going into the board, so I'm going to do my loop line integral in a clockwise direction. So I'm going to start here, work my way around clockwise. We'll call this path A, B, C, and D. And like before, we're just going to break this line integral up into the four different parts. So we have the integral of B dot dl, use slightly different notation along A, plus the integral along B, plus the integral along C, plus along D. And that's going to be equal to this mu naught epsilon sub naught E dot A All right, so I got my four little integrals over on the left-hand side. Which ones are going to be 0?
The ones that are perpendicular.
All right.
So D and B.
Because B, again, is up this entire time, and in B and D, we're moving sideways. So along my first segment here, I have BH. And along this last segment, I'm going down, because again, I'm trying to get back to where I started. I'm coming down, but my magnetic field is going up, and so the dot product will be a negative B plus dB times H. And over here, my electric field and my area vector are in the same direction. So this becomes mu naught epsilon sub naught A times d E dt. And A is the area of this arbitrarily sized box. Well, partially arbitrarily sized. All right. On the left-hand side, I distribute the H, and the BH's cancel out, and what I'm left with is negative H dV. And that's equal to, on my right-hand side, mu naught, epsilon sub naught. My area is H dx times the time derivative of my electric field. Exact same process as went through before. I have my dx on the right-hand side. I'm going to bring it over to the left-hand side. My h's cancel out. I don't want to forget the negative sign because I did last time. So I get negative dv dx is equal to mu naught epsilon sub naught times dE dt. And now we do the calculus. Negative. What is dB dx?
dm k cosine kx minus omega t.
That's equal to mu naught epsilon sub naught times the derivative of the electric field with respect to time.
em negative omega sine or cosine kx minus omega t.
We get rid of the nasty stuff, get rid of that trig function there. We got negative signs we can get rid of. And I'm left with the magnitude of the maximum value of my magnetic field times K is equal to mu naught, the permittivity of free space, times the permeability of free space. I said those backwards. Permeability times permittivity times the magnitude of, or amplitude of my electric field times omega. Again, I want to get omega over K because I'm trying to find the speed here. So I bring this up, I bring this over, and I have omega over K is equal to dm over mu naught epsilon sub naught em. And so now I have another expression for this, and any questions up to here before we put in the last little bit?
Can we not substitute head?
Sorry?
Can we not substitute the omega over k in for the other section and then somehow cancel the e's and the m's out?
We're gonna do something very similar to that. That's the last little bit. We're not gonna cancel them out. We definitely need them. But yeah, we're gonna equate that to what we have over there. And I was looking for just that perfect marker, the one that will say we are celebrating physics, and I'm gonna settle for this one. So I now have that the electric field magnitude, the maximum value of my electric field, or the maximum value of my magnetic field equals Bm over mu naught epsilon sub naught Em. I'm going to multiply both sides by Em over Bm, so I get Em squared over Bm squared is 1 over mu naught epsilon sub naught. I know that my speed is E over B, so if I just take the square root of both sides, get EM over BM, which is the speed, which is the square root of 1 over mu naught, over epsilon sum naught. And that is the equation. I would like to know what was going through Maxwell's head, though, when he was looking at this and doing, huh, let's go down this path. Let's see what we get. Or was he feeling really confident that he knew that understood the material so well that he thought, oh yeah, I bet this is light. And this we can calculate 1 over 4 pi times 10 to the negative 7th Tesla meters per ampere times 8.85 times 10 to the negative 12th Coulomb squared per Newton meter squared.
Should be 8.99 e to the 16th.
Then square root.
Oh. Or 2.99 to the 8th.
That's 10 to the 8th.
Yeah.
And the speed of light officially is it's usually front cover or back cover. There we go. Speed of light 2.99792 458. You know what? No, just do it like that. Speed. This is now considered the speed of light. At Maxwell's time, I don't think they had established it as definite. At this point, the speed of light is definitely this. That is the value.
Is that,
At his time, were permittivity and permeability experimental numbers, or were they
Yeah.
derived?
Permittivity would definitely be an experimental number. Permeability, I suspect, was an experimental number,
Okay.
because I don't think enough stuff has been established as we're gonna set this as our standard. Oh, what if we forget?
Direction.
No, it's speed.
units,
Thank you. What are the units?
meters per second?
Yeah.
Oh, that's not down there.
Oh, I forgot it up there. Sorry, I did have them down there. And if you work through the units there, it will work out. I have great faith that it will. I'm sure I've done it before. Really confident. Why don't we take a break there? We come back. We will talk about the implications of this. I know we mentioned it before, about the mistake and where Einstein came along and established a whole new branch of physics back when it was thought that physics was almost done. So, take 5. And I'm just gonna let that run. Assuming that it's running. And if anybody wants a hamburger, they're right here.
Next Tuesday, quizzes and Thursday's master set. And next Thursday, we also have multiple choice test. Yeah. Yes.
numbers.
And the lab for this Thursday, there's nothing different, at least as of right now. And then we're just about done.
Then we have to test the next one. Okay, the test for Thursday is, the chapter.
Up to what we did today, pretty much. I think specifically like up to here. You know, like I said, there's no, relativity on the multiple choice. Yeah, the one we took the first day class. Yes, this might not be that. Rossi Hall.
Could have been, I mean.
Yeah, you got a lot of Coca-Cola collectibles.
True. Got to collect all your bottle caps.
You'd be surprised at what, like the knickknacks and stuff they come out with. It's just, I guess, because the brand's so big.
Yeah, but
You going to Raleigh next weekend?
Yeah, it's not, it's
Yeah.
purely conceptual.
Yeah.
Yeah.
It's that, the first semester,
Yeah.
the first day.
First
It's
time
just
seeing the
like
campus in
that.
person, so I don't know how it's gonna be like. You been there before?
Yeah.
it's a lot bigger than you think it is.
Or, I seen pictures online, it looks nice, I'm not gonna lie.
We're gonna be on the Centennial campus though, so we'll be kind of away from a lot of the stuff.
Mhm.
Make sure you look at the bell tower while you're there.
Yeah, that's it.
Yeah.
They don't have a lot of tourists.
No, but. If you go to NC State for a tour, you gotta look at the bell tower. I don't know why. Man, it's pretty, but that's where they run to, like after their football team wins.
Hmm.
Uh,
Yeah, I might walk around the whole day just to get to know the place.
Well, you can do it. There's a Mexican restaurant, right across from the bell tower,
Mhm.
and that's really
You
good.
been there?
Yeah.
Gonna be there freaking all day,
Yeah.
9:30 to 3:30 or something.
Yeah. Oh, it's the whole day? I thought it was like you have to go at some point in time, in there.
I'm pretty sure we gotta be there for all 6 hours.
Oh, yeah. I just didn't want to get up early, but.
Early,
Yeah,
9:30? Are you kidding me?
I don't like getting up before like 8.
Man,
You'd have to leave at 8, cause it's an hour and a half away.
Exactly,
Well,
so I just have to get up like.
call it
7 or
7:30 so you
something.
can get parking and walk.
I'll be in Raleigh Friday night, so I'll only be driving 15 minutes.
Yeah, I need to work on getting sleep. I'm waking up really fast. I can't. It is weird because I can't fall asleep either. Like, I've been going to sleep like at 11, so I'm laying awake at 1, 2. I can't fall asleep. I'm just laying in bed, tossing and turning. And because of that, I wake up like 9, 10.
I used to wake up at 4.
Yeah, I'm up at 5:30 every morning.
I used to wake up at 4, and I used to leave the house by 4:30 for one of my old jobs.
Ugh.
And I started last semester, I started a class and it was like 6 o'clock at night and went till 9. And it ruined my sleep schedule. So I used to go to bed at like 9.
Based on the pictures I saw from the traditional students that have already gone through this,
Mhm.
it's gonna be formal attire too, so we gotta wear a suit.
Mm. Like full blown suit. Or,
With a suit out in the sun.
yeah, that's what I was thinking. Yeah. Wait, where did you see that? You said you saw like previous ones or?
Yeah, like on, I think it might have been Twitter, like Goodnight Scholarship Twitter. They took pictures of all the high school kids coming in for first year, cause they have 50 of those also.
Gotcha.
Everyone was in formal attire.
Yeah, because friend that got it last year, he said, that he wasn't through a Zoom call, so it was like, just throw it on for the call real
Yeah.
quick, take it back off, as soon as you're done type of thing. They had the option to do the interview, I was, fine, but I was like, I'd rather just go in person. Since I haven't been there before, might as well get to know the campus too.
It's a lot easier to make like a connection with somebody in person too.
You build trust. Yeah, like, and, like they said, you don't get points away or nothing like by not going in person. I don't know, I feel like it shows like, it's only positive to go compared to, you know, holding it online.
Unless you're wearing like a tuxedo t-shirt, but on Zoom it just kinda looks like a tuxedo. Then it might be beneficial to stay home.
We'll see how it goes.
I'm excited.
And I'm wondering when they send out like the financial aid information, cause I kinda need that to apply for housing anywhere. They like provide documents that you're gonna have so and so to pay for housing or whatever. So, right now I can't really do much until I get that. Either a financial aid package or a scholarship if I get it.
Get another email in 2 days. It'll tell us more information about it all.
See, I don't have much experience with interviews in general. I think I've only had like two in their job interviews, so.
Yeah.
I'm like, yeah, I wish I could maybe be more prepared for what they're going to ask for.
I
But
think,
my friend, I asked him like, and he was like, well, they want you to hold a conversation, they want to get to know you